Beneath this water, trains cross through one of engineering's boldest hidden worlds.
Britain and France are close, but this narrow sea shaped centuries of separation. The dream of a tunnel began long before machines were powerful enough. The channel was shallow enough to tempt engineers, but dangerous enough to stop them. The hardest part was not the sea above, but the ground below.
Engineers needed one stable layer, chalk marl, hidden beneath the seabed.
Before digging, they had to read the seabed like a buried map. Too high or too low, and the project could face unstable ground.
The Channel Tunnel is not one tunnel, but 3 parallel worlds. The Central Service Tunnel became the hidden spine of the entire system.
From both shores, crews began digging toward a meeting point no one could see. The machines were not drills. They were moving underground factories. Steel teeth carved the chalk while the tunnel formed behind them.
Every meter excavated had to be sealed, supported, and measured.
The machines created a river of chalk that had to be removed. On land, millions of tons of spoil became part of the project's footprint. Deep underground, tiny errors could grow into enormous problems. British and French teams were aiming for the same invisible point.
Above them, the sea pressed constantly against the buried worksite.
In fractured ground, machines had to hold pressure as they advanced. The French approach faced more folded, fractured, and water-bearing geology.
The British drives still demanded precision, endurance, and constant geological monitoring.
Inside the tunnel, every task depended on discipline, timing, and trust. Cut, clear, line, measure, repeat. The tunnel grew by controlled rhythm. The undersea section stretched farther than any tunnel beneath water before it. 3 tunnels advanced like a hidden railway system forming in the earth.
Cross passages turned separate tunnels into one connected safety network.
The service tunnel allowed crews to reach places trains never see. A tunnel this long needed engineered air, not just open space. Even controlled seepage had to be collected, pumped, and monitored. Behind the concrete, power and communication systems made the tunnel alive.
A hidden control network watches the tunnel every moment of operation.
The engineering was difficult, but the financing became its own battle. The tunnel was built through private finance, carrying enormous commercial risk.
No machine could succeed without cooperation between 2 nations.
Safety was designed into the tunnel long before trains arrived.
The service tunnel gave the system a protected route through danger. After the digging, the empty bores still had to become a railway. Steel rails transformed the tunnel from a passage into a transport system. Electric power had to run reliably for 50 kilometers underground. Signaling systems would control movement where drivers could see almost nothing ahead. Before passengers arrived, engineers tested systems most travelers would never notice.
When the service tunnels met, Britain and France touched beneath the sea.
The breakthrough proved that years of underground measurement had worked.
The rail tunnels followed, completing the hidden skeleton of the system.
After years underground, the giant machines finally stopped cutting. The hardest-looking work was over, but thousands of details remained. Power, drainage, ventilation, communications, and control had to work as one.
Test trains entered the tunnel before the public ever did.
In 1994, the tunnel officially opened a new route through Europe.
For travellers, the impossible became a scheduled journey. Cars and trucks could now cross the channel without touching the water.
Freight turned the tunnel into a moving artery for commerce. High-speed rail made the tunnel part of a wider European network. Inside the train, the engineering disappears into comfort and routine. For 20 minutes, passengers move through a world beneath the seabed. The tunnels run roughly 40 meters below the seabed on average. At depth, pressure, water, and geology never stop testing the design.
A mega project is never finished. It must be maintained forever.
Engineers watched the concrete, joints, rails, cables, and drainage.
Every crossing depends on timing, spacing, monitoring, and control.
Inside the tunnel, safe spacing matters as much as speed. The tunnel was built for fast travel, but safety governs every movement.
A fast train pushes air through a tunnel like a moving piston.
Engineered airflow keeps pressure changes controlled and predictable.
Passengers feel calm because hidden systems are constantly working.
The visible train is only the smallest part of the machine.
The tunnel's safety depends on preparation, not improvisation. Every journey passes through infrastructure shared by two nations.
The tunnel begins before the portal, in vast terminals on both sides.
Vehicle shuttles turn roads into rail traffic for the crossing.
A train leaves daylight, carrying road traffic beneath the channel.
The Undersea run is the tunnel's most extraordinary achievement. Even today, the tunnel's story is still written in chalk. The route passed near ancient geological features hidden below the seabed. The tunnel did not defeat nature. It negotiated with it.
Water, pressure, cost, alignment, and safety all threaten the project. The answer was not bravery alone, but disciplined engineering.
Thousands of workers turned drawings into a path beneath the sea.
The machines were enormous, but human judgment kept them useful. The project moved through nights, shifts, delays, and constant pressure.
The final cost rose far beyond early estimates. The price was huge, but so was the change it created.
The tunnel became a permanent route for people, goods, and time.
Major cities felt closer because the sea was no longer a barrier.
The greatest infrastructure often becomes invisible when it works.
Behind every smooth crossing is a world passengers never enter.
The Channel Tunnel is less a structure than a living system.
Its success depends on decades of inspection, investment, and adaptation.
Modern infrastructure must survive weather, demand, politics, and time.
The tunnel's deepest lesson is precision under pressure.
Ambition only worked because engineers respected the ground.
Under the sea, the tunnel performs its miracle quietly.
A journey begins underground and ends in another country. The Channel Tunnel changed not the distance, but what distance meant.
It is concrete, steel, geology, finance, and trust combined.
A centuries-old idea became real because every detail finally aligned.